Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon. So today we'll present my project for Utem 2021 by the title of Intelligent PD Antenna with integrations of noise suppression patches in combination with hybrid PD SOM and statistical extraction feature certifications for power transformer. Noted that this project has been registered UK copyright number 284739260. So this is my project. So currently I'm the project leader. I'm from Faculty of Electrical Electronic Engineering and Technology, Utem. My advisor is my PhD supervisor also, is Associate Professor T.S. Dr. Muzami bin Isa. And below are listed of my family member, research members. Alright. This is my agenda for today. Start with introductions, problem statement, novelty inventiveness, product descriptions, picture, data and result and discussions, advantages, and conclude with communications and others. As a brief introductions, so transformer started as a finding by Michael Faraday that discovered the electromagnetic inductions, and then in 50 years later, first secondary registered are being made by Suppression, and then the first ring-shaped transformer being designed by Hungarian transformer before Stanley buy the patents and also improve and use it. This is in 1886 the early design of a transformer by W. Stanley. At the small, and over the years it keep increasing by the sizes. Okay, so finally in today 2021 a modern all-power transformer currently the most the biggest equipment in our substations and the most expensive one. All right. So according to IEEE standard 493 for person failure, it's conducted over 2,000 power transformer. 8.7% dry type varied from 300 to 10,000 kVA are failed, whereas liquid type more than 10,000 kVA fail about 3.3%, and liquid type 300 to 10,000 kVA fail about 88%. Therefore, it can be seen that liquid type, even though it reduce the overall size and also improve the reliability, when we don't solve on the partial discharge issue, it will fail much more higher compared to dry type. Alright. Before I continue, let me talk about PD or partial discharge. So PD is a localized dielectric breakdown when our transformer have void, crack, occlusion, especially on the insulating part. And it keep increasing when we have appropriate amounts of electrical and mechanical stresses, right? According to Kruger-Mohs quality global, PD is related to insulation health and is a main contributor to insulation failures in power transformer. So the insulation degradation, it can be due to aging, the transformer operate more than 10 years, environmental issues, mechanical operational stress, or it can be from the earlier causes such as manufacturing defects, right? Even though PD happen in very minimal magnitude in picocoulomb and short period microseconds, but the recurrent activity will produce more significant impact on the installations or the transformer. Alright, based on the PD overview, there are four main types of PD. We have internal, electrical, corona, superficials. The difference between these four is on the evidence, because if we say corona, it's not coronavirus, it's corona, PD corona. It have a heat, salts, powder, nitric acid, ozone deposits in our transformer, alright, in our equipment. Whereas for my focus of research, internal discharges, it's invisible because it happened inside our transformer main tank. Go to problem statement. I listed four main problem statements. Start with the problem with detection internal PD that happen in main tank, that mostly according to the Yan and Krillin, we need all sampling, and this poor handling will have impact on sample contaminations and also it time consuming. Whereas Boruki, Chikon, Hamamatsu, Quartz, and Zurilla said that this current technology that we use to detect PD are vulnerable to noises, especially on electrical and mechanical noises. Then, according to Yasuma Stone, Seagulls, and Kevin Montanari, false information from integrated, especially when we use an integrated and uncalibrated sensor, will produce a false alarm. And this is not something that we can accept. And last but not least, Bashar and Hudon Abilek, currently PD detections are to rely on PRPD patterns that it currently needed expertise persons to do an accurate interpretations of signal being collected. Alright. Okay, for time consuming, it takes months before decision can be made. So it is hazardous to transformer healthiness and reliability, because when PD happens, the severity itself may impact the operationals. Okay, we may because both based on my experience where I worked in TNB before, we have transformer that caught on fire due to PD. So these decisions is very important to preserve our transformer. Next, when you say substations, normally it's crowded with internal and external noises. It can be wide or random noises that vary throughout the frequency band. Okay, and then the internal or the integrated sensor. Okay, false alarm can happen. So this is something that we want to prevent, because false alarm meaning we have to shut down the transformer without any problem because of the sensor problem, the uncalibrated issue. Next, when you say this is the signal being collected by PRPD, being transformed into PRPD, you can see that the signal itself are being clouded by multiple. We have background noises, we have internal PD, we have pre-potential. So this is something that have problem to be identified, to be classified, especially for our personnel, okay, TNB personnel. All right. So the comparison study compared to my prototypes, okay, this is my PhD, and so compared to conventional equipment, it is costing a mere 100 ringgit, about 25 US dollar, and it's portable, lightweight and portable, 95% lighter than we have equipment Mega UHF PDD that being used currently, and performance both are high. And when we say heavy bulky equipment such as mega UHF, it needs casing for measurements because it is bulky and heavy. But my prototype of sensor are built with tripod stands and portable, easy for transportations, right? And frequency range that being used currently for mega UHF are 150 Hz, 50 Hz to 1 GHz, where my target is antenna bandwidth of 300 to 3 GHz, more than 300% of frequency coverage. That is the most important things. Not that it is cheaper, it's lighter, built with for easy portable and better frequency coverage. Alright, in terms of novelty and inventiveness, I offer four main contribution. First, these systems that by offer can be offer on-site analysis. It can be rapidly analyze the result, and the design itself are portable and easy to be calibrated and replaced. Okay, and then because of noise that happens inside our substations, we need a noise filter. Therefore, I introduce with integrated novel noise suppression patch that replace the conventional noise filter or noise filtering circuits. And finally, AI recognitions with hybrid statistical reduce the needs for scale personal evaluations, where the classification results are classifying the data collected according to its attribute, especially for severity. All right. So this is the PD section flowchart. Start with selections of material and determinations of optimal sizing, introduction of slots, integration of filter, and we get the desired optimal antenna performance, especially on the scattering parameter, S11 with SWR gain, surface distribution and radiation patterns. And then I fabricate the antenna using photolithography methods and chemical etching before I go for characteristic study and compare with reference antenna. So this antenna used to acquire a PD signal data via prototype and also verifications with the antenna that being used currently by such as mega antenna. So we do a comparison, especially on detections. Next, for recognition, start with determine the PD characteristic, especially for IP standards, and initialization of some input to generate weights, training and learning phase. And because we based on SOM and also in combinations with statistical, it have a training learning phase that measure between data nodes to select the best matching unit, update the BMUs, and finally we have an optimized PD recognitions and qualification, especially for severity study. Alright, so prototype descriptions. We have multiple cynical slots. So this is the inventiveness where I reduce the overall sizings again with simple slots that have excellent reflection coefficients and also improve surface current distributions. And again, the novel noise separations produce a better and accurate PD detections because it reduces the overall noises. Next, for the AI recognitions, this using a MATLAB SOM and in combination with statistical features, 9 features to improve and do accurate PD recognitions. Okay, all right. Show only 3, we have 9. Okay, this is the statistical, and this is the PD detection and recognition setup. Started, we have a targeted lab site transformer, and is identified and ready with real PD signal. So The antenna is set according to the transformer locations that collected the EM signal and filtered by my novel patch. And the final signal that collected are processed using AI PD recognition to determine on PD severity. Right. When we compare PD detection results, the orange color and gray color. Gray is the conventional antenna, where my proposed antenna are producing clear signal, clean signal, better signal with a good PD detections. Therefore, it produces an accurate and less noise for PD detections, especially for orange waveform, compared to the monopole antenna that been used currently by the reputable manufacturer. All right, this is the design that been used by industry level. Next, for PD recursion result, you can see that for these simulations, I compared. I have a few inputs that mix between the normal signal and also the PD signal. You can see that the severity compared to the normal one are being clustered. So this is the most important thing, because we don't want our decisions that we put into risk, especially our transformer, are the one that have a normal signal compared to the PD signal activity. All right. So in terms of advantages, prototype over conventional, the first ones, okay, it produce an accurate and fast PD detection and recognitions less than 5 seconds. Whereas with the conventional ones, it take more time to detect and classify the PD. So this is something that we want to contribute. Next, when you use a patch antenna, okay, especially it can be rapidly manufactured because using the existing PCB equipment available in the industry, whereas for the required special equipment for manufacturing, especially on the whole module and the antenna. And with my integrated noise suppression patch, it reduced the needed for extra filter circuits. And and comparing with the conventional that they need additional filter, and also they are exposed with ambient that will produce a false noises. And my recognition, especially on the severity, proof and produce a simple reliable AIPD, whereas for conventional way to detect, to classify, need a trained personnel to do accurate recognitions. And last but not least, my design is small and miniaturized and portable compared to the bulky design that being used by conventional type. This is my commercializations. We have a few discussions before that involve the MB research at Aduta Azams and head of HP testing to test the whole setup into MB stations, especially after the MCO2 ends. And because of these equipments have the possible commercialization, because in Asia we have few, not only we have power utilities such as the NB, we have CSB, CESCO, we have also IPP that can use this equipment for their equipment. So future plans, we are filing for industrial patent design before proceeding with industrial pitching, because we want my design, my antenna design to be integrated reality system to increase the applications, so on and so forth, right? So this is the publication related to the product. I started with the scopus. I have 3 scopus paper and 1 IEEE conference, or it's also scopus index. And this is my achievements. I have registered by UK corporate. This is my sets, and also Alhamdulillah, I achieved gold awards. We entered to Eureka early this year. Okay, gold award this year. This is my achievement. Because of this design, have some contributions that possess the important criteria for a good PD antenna, PD recognition and also detections. And this is my reference. Okay, this is a reference. All right, thank you very much. Assalamu alaikum warahmatullahi wabarakatuh, and thank you for your time.